All right, so the next thing the lab asks us to do is to answer questions parts C and D. All right, so the question is back here. It's a little hard to read back here. Again, you can download the book page from the website. It is page, what page is that? Page 137, and we're looking at number 20. Let's put that on here, page 137, number 20. All right, so now we're supposed to be using trace mode in our calculator to answer these questions. So here I am in trace mode. My time is 5.9. I'm at negative 36. So let's go forward in time until I can see the particle. Actually, I guess we want to go back in time. So I'm going back in time to bring the particle back on screen. There it is. And there it goes off the screen. Okay, so part C says, when is the particle at rest? Now, we're only going to be able to deal with when we can see it on the screen. So we might want to bear in mind, we first start to be able to see the particle at t equals negative 0.1. By the way, this term particle, of course, is from physics. You're going to see the AP exam use that word a lot. Instead of an object moving back and forth, they'll call it a particle, because it could be a particle in a particle accelerator. Could be, by the way they do meteorology and climatology is we talk about like packets of air that have various properties, and then they're moving around. So it's just like you analyze the flow of air by looking at just like a representative packet and what that little packet is doing. Particle, that refers to a small object moving around. Sometimes we're interested in that. All right, so when means what is the value of t? When the particle is at rest, when it's not moving, okay? So it's moving, it's been moving the whole time. But when I get to this point right here, see how it stops moving? So I'm pressing the time forward, now I'm pressing time backward. And right about there, that particle stops moving. So we want to, now everything we're doing in this lab is sort of by estimating, what apparently looks like the time when it stops moving. It looks like something around 1.4 or 1.5. That particle is not moving, right? Maybe 1.2. You could, well, yeah, I think you could make a case for, let's see if I can watch this really carefully. Right there, I think. Yeah, it's like 1.5 or 1.6. So I'm going to say t equals approximately 1.6. All right, now we're going to keep going forward in time because I think it also stops moving right there, doesn't it? Right there. So an important idea is the object can't reverse direction without stopping. Yeah, I think probably right about there. It's like 3.1-ish. So these are estimates. It looks like it's about 3.1, but these are seconds, okay? So it looks like, and where did I get these numbers from right there, the t value? All right, so that's my best answer for C. All right, part D says describe the motion. All right, so I'm going to go back to where the particle is off the screen. So you're going to go back here. And so when I have t equals negative 0.6 and lower, so this is the beginning of time, negative 1.8 and so forth. So if I run the simulation forward in time, you can think of this as a simulation. So I'm running forward in time. The object comes from very far away. It comes from positive infinity, moving to the left. Then it changes direction, moves right for a bit, and then it turns around and runs back to the left and appears to run off to negative infinity. So my description of the motion would be the particle travels from positive infinity to the left, then briefly reverses direction to the right, then reverses direction again toward negative infinity. So basically that's a way of saying that the particle comes on screen from the left, turns around briefly, and then goes off to the left forever again. So this, by the way, is, remember that your cubic, the function was a negative cubic. So the function actually looks something like this. Is that what it looks like? Is that what I think it looks like? Because we're moving to the left when time is positive. Maybe I need to think about this a little more. That's a negative cubic, right? Yeah, okay. So when we come from negative infinity time, so basically time sweeps across the time axis here, right? So time is sweeping across the axis. So what does the object do? Its position is decreasing, then its position reverses direction and starts increasing. That's here. And then it begins decreasing toward negative infinity. So the position we can see going left, then going right, and then going left. So for a position graph, when the graph is decreasing, the particle is moving to the left. When the graph is increasing, the particle is moving to the right. And when the graph is decreasing, the particle is moving to the left again. All right, so this is basically what the description looks like. All right, and then it says, the question says, at what value of t does the particle change direction? Well, so as we were looking at, where are we time-wise? This is 7.2. Let's go back. So you probably can answer this question fairly quickly. Yeah, because it's really the same question as part C, right? So when does the object reverse direction? Here we are going to the left, and now we're going to the right. Okay, at what time did it reverse direction? Well, it reversed direction at about t equals 1.6 again. So for the second part, it reverses direction at about t equals 1.6 seconds. And again, moving forward in time, watching the particle reverse direction right about there. All right, so again at about t equals 3.1 seconds. So just conceptually, the particle at rest and the particle reversing should correspond. In fact, they must correspond to a certain extent. So here's the trick that we're going to have to be dealing with in the future. In order for the object to reverse direction, the particle must come to rest. However, the particle could come to rest without reversing direction. So I could have more numbers up here than I do down here, but every number that occurs here must be in this list. All right, so that's a little bit about coming to rest and reversing direction. And that's part C and D of number 20. And we'll see what we got next.